Okay, this is a 2004 Dodge Caravan with a 3.3 liter engine. And the history of this vehicle is it just had a timing chain replaced. And the chain was replaced because of noises. There was no issues with drivability or trouble codes. And after the chain was replaced, we have these trouble codes in memory. We're not too much worried about the top one, the O2 heater circuit fault. We're addressing right now the P0344 cam sensor circuit and the P0016 crankshaft camshaft timing misalignment. When you have this misalignment or correlation trouble code, of course our first thought is this timing off? Is the chain off? And most of the time I have to tell you that it is. You have a camshaft, crankshaft correlation trouble code, timing chain, timing belt wasn't put on right or is off. I have seen though a faulty sensor cause this, one that's glitching or dropping out. So I think our next step before we would pull these covers off, which is not easy to do on this engine, is we need to look at both our camshaft and our crankshaft signals. So that's where we're going next. Oh, one more thing before we do the cam crank waveform is there's some data parameters we can use on this vehicle for some guidance, and that would be our cam and crank sync state signals. They both say no, and what we should see with the engine either cranking or running is we want these to say yes. Now, warning on these, you have to be careful that if you have one that's dropping out saying no, you have to be aware that it can be either sensor that's faulty. So in other words, you could have a cam sensor signal that's saying no, yes, but it's actually the crank that's dropping out and glitching. So just be careful using them. We can use them as a guide that we're going in the right direction, but don't use them to pinpoint where your problem is. It is interesting that initial view it's saying that it's good. Let me rev it up, see if we can hear the way this thing's running. High RPM is when it's breaking up. So it idles pretty good. Under a rev, you can hear it. Get another shot of that when I shut this back off. Alright, you see now we're no on my cam sync state. So really not necessary for this video to go through that stuff, but it is a guide that we are going in the right direction. Let's take a look at these waveforms now. Scope I'm using for this video is the Pico scope. I have my blue channel, channel A, connected to my crank signal, and channel B connected to my cam. I'll get you a quick shot of where those are at. Okay, the cam sensor signal, I'm getting at the connector, which is underneath the throttle body here, and I have my channel B lead connected to the signal, and I'm actually using the sensor ground, the cam sensor ground, for my ground location on the scope. And the reason I've chosen that instead of battery ground on this vehicle is it just gives you a little bit cleaner of a signal on the scope, eliminates some noise and interference that you may see. So channel B, red trace, is going to be my cam sensor signal. And then my crank signal, I'm not going to be able to show you where I'm connected here. It's underneath the vehicle, or underneath this exhaust crossover pipe, and it reads off of the flywheel. So this connection, my channel A, is going to be connected to the sensor itself, the T-pin that I have in the sensor connector underneath this pipe. I know what you're thinking, so might as well tell you now. The other two leads in this picture, the green and the yellow, I'm actually connected to one fuel injector right here, control wire on one of the fuel injectors, and then the yellow lead is going to one of the coil primary control wires. So I'm going to show the injection and the ignition within this too, but let's start with cam and crank signals. Okay, of course it helps to know a little bit about the type of sensor you're connected to and what kind of voltage signals you're going to see. So these are Hall effects. They're going to create square wave signals of 0 to 5 volts. My setups for channel A, I set it to plus or minus 10 volt, and B plus or minus 10 volt, and that of course gives me the ability to move things around and have these signals separate from each other. I'm going to start it. So the first view with this would be to take a look at these signals and see if we see any dropout, in particular the red trace, which is the cam. And these look actually pretty good initial view. Nice consistency within the waveform. I don't see any glitches or dropouts in the signal. Ignore the voltage spikes in there. I'm getting a little bit of interference from ignition injection components on the vehicle, but the red trace again is the cam, the blue trace is the crank, and these look pretty good. I don't see any issues here, at least at idle. But remember, this thing breaks up under load, so let's retake this capture, you know, at 2,000 RPM when this thing is acting real goofy, and see what it looks like. You heard that long crank time too. That's another symptom this thing has, is a long crank time. I'll hold my RPM up. Take a look at this zoomed in. We'll go back a couple of frames. This thing was acting real goofy. You heard it surging very bad. So what we want to look for is our cam and crank signals. Are they dropping out? Are they glitching or changing on us? In particular, the cam signal, the red trace. And those look pretty good again. One of the hard things about using a scope, especially if you're unfamiliar with it, is when you see things like you see things like this. You know, is that a problem? You know, you see one up here too, and the best thing I can tell you is experience is going to teach you these variables on what you're looking at, what your problem is, and what might just be noise that's in the circuit. Guys, that's just noise. That's not an issue at all. As you can see, when this thing is surging, we are not losing our cam signal. Again, our focus is on the red trace. It looks pretty consistent. And the setup on these, of course, helps to know too that Chrysler has used this design cam signal for a long time. This 1 2 3 1 2 space pattern has been used for a long time on this 3.3 engine. So it looks pretty good. I don't see a breakup in this signal. So what we're saying right now is It's not a sensor problem. Our cam sensor trouble code, our cam crank correlation trouble code, it's looking like this is going to be a timing issue, that the chain was put on incorrectly. And what we're going to do in this case is we're going to take this waveform, let's go back in, and we're going to pick, you know, a spot or two on the waveform and compare it to a known good. So, you know, we'll put a cursor in, maybe, you know, you could pick a pulse, it really doesn't matter. Pick the triple pulse and see where it lines up with the crank, or you can pick the single one, see where it lines up, or the double, or even the space. And what we need to do is find a known good waveform to go by. So one of the things I've tried to do over the years, and this is a suggestion for some of you guys too, is to start saving waveforms from known good, known bad vehicles. And so I'm just kind of looking through my database here, looking for a Chrysler 3.3. I'm pretty sure I have one in here. There's a 92 Caravan 3.3 cam crank. Now I know this is an 04, but see, this one had a misfire. I don't know how well this is gonna help us. Okay. I can definitely see the same kind of spacing within the cam signal, that 1, 2, 3, 1, 2 space. But the interesting part with this is the crank signal is completely different on this older model year. So that is really not going to help me, and that's of course a concern. So what do we do? What do you do when you don't have a waveform to go by? Well, I want to share something with you guys, a network that I use all the time, and that is iATN. So that's International Automotive Technician Network. And there is a free version of this, and there is a paid member version. I am a paid member, and the cost is relatively cheap. It is cheap. You're only talking $45 or so per quarter, so every 3 months. So worth every penny for what you're going to find information wise on this website. So as a paid member, I have the ability to search a waveform library. So go to my knowledge base, go to my waveform library, and this is what I did previously. And what I want, I don't care if it's a drawing, schematic, it doesn't matter in my case. I need to have a known good waveform for this vehicle. It's an 04 Caravan, so I'm going to pick the model year 2004 to 2006. I'm going to pick all Chrysler because I really don't care if it's a 3.3 and a different engine. And I got 469 records here. I'm going to narrow this search a little bit, and I'm actually just going to put in the engine size, which is a 3.3. And this will be all the sensors or waveforms that are uploaded on this model year range, this engine. So I have 26 records. Hopefully within here I'm going to find a known good cam crank relationship waveform. And the first one that I picked, and this is by Kevin, forgive me Kevin if I pronounce your name wrong, Sutorp maybe, forgive me, and he uploaded this 2005 Caravan, and this is on the 3.3, and this is nice. This looks like a picture maybe taken off of the Veris or the Modus, one of the two tools. And so you see our crank waveform looks like ours. This yellow trace is the crank and the green trace is the cam. And what I did yesterday is I looked at this. Well, first of all, it helps to know that this is known good, so very nice of Kevin to put this information for us in here, that we have this as being a known good. And some other stuff he has too. He's got injection timing in here and ignition firing event. But my main focus right now is this cam and crank signal. All right, what I looked for when I saw this yesterday was I looked at the spacing of this triple pulse. That was the one that really stood out to me, that it's way off from where I'm at. I mean, if you look at the triple pulse on this thing and you see the lower portion of the crank signal, so you got the high high portion here, the lower portion here. You see the middle triple mark here. And let's go back to my waveform, take a look at it. And if you look at where the triple notch is, that's the one I chose to really focus on. Compared to, again, I said the low portion of the crank, it's nowhere near where this one is. Nowhere near. Not even close. So what that's suggesting is this timing is definitely off. I did some measurements on this yesterday, and we don't need to do this, but I had it calculated at like 114 degrees off, and that's as simple as pulling in some cursors and knowing where your cam and crank signals are. So if you put a cursor here and you put a cursor here, that would be one complete rotation of the camshaft, which would be 2 rotations of the crank. And then you can calculate your number of degrees per millisecond. Then what you can do, and this isn't exact, but I put a cursor roughly where I thought the triple notch pulse should be, which was in there, and then I measured from where it was and the distance in there, and I had it calculated to like 114 degrees off. Well, if we're 114 degrees off, how's this engine running? So let me pause for 1 second and give you a shot of what the engine vacuum is on this thing. Okay, I got a vacuum gauge connected. Gonna start it. Sorry, my gauge is upside down, but you get the idea. We got, what, 18, almost 19 inches of vacuum at idle on this thing. There's no way that this timing can be that far off with the chain and have this kind of engine vacuum readings. So something doesn't fit here. Look, we're almost 20 inches of vacuum. Something doesn't fit. We're missing something. Okay, back to my computer here and back to iATN. So I did a little bit more digging, and we'll come back to this picture here in a second. And the nice thing is there's some other waveforms that are in here too, and this one is by Eric Rupert. Again, forgive me, Eric, if I pronounced your name wrong. And this one I found very interesting because it matched almost identically where my triple notch pulse is compared to the crank. So let's look at this one. Let's look at Eric's picture. Look at the triple notch on the cam compared to the crank and where this low portion is. And let's take a look at mine. And man, does that look really, really close to where his is. Now, I can't put cursors in his picture because I don't have the original file, but just to give you a visual perspective from this middle of this triple pulse to the low portion of our crank. Let's go back to his picture. Look at that. I mean, that's identical. So again, the cool thing about being a paid member to this site, we can read in a forum post where they were talking about this waveform. Let's see what we got here. And as I scrolled through this, what I found, and it was nice to see that that Kevin, the guy that the waveform I used previously, actually replied to this one. Let's read some of these messages. And there's a comment of something about a cam gear and a later flex plate, and I'm looking at that thinking, well, did they change the cam gear on this year? And I scrolled through a little more and I found Eric thanking Kevin, the correct cam sprocket has been ordered. So what's that tell me? I didn't know anything about this. I did not know Chrysler changed the sprocket. Let's go back and take a little bit closer look at this. And again, this is Kevin's waveform, the known good. And let's look at some patterns here that I missed when I looked at this at first. And what we see within his pattern, if you look at it, we got 1, 3, 1, 2, 3, 2, 1. That's completely different, and I didn't see it at first to what we have. Let's look at mine. Mine goes 1, 2, 3, 1, 2 space, 1, 2, 3, and then repeats itself. 1, 2, 3, 1, 2 space. Back to Kevin's 1, 3, 1, 2, 3, 2. This is the wrong gear. this camshaft gear, let me take you over to the desk here for a second. And after I saw this yesterday, I asked the owner for the original cam gear, and fortunately he saved it. This is the one that came out of it. Here's the chain, and our focus though is going to be on this cam gear here. That if you look at the teeth that are on this and maybe follow it like the waveform showed, so picture the camshaft, or yeah, picture the cam signal being right here, or cam sensor. It's going to read these windows. I'll just leave it where it was. These windows right here, not the teeth outside, but these windows is what's going to pick up that signal. You see 1, rotate this, 3, 1, 2, 3, 2, 1. Exactly the pattern that we see on the screen from that waveform, but not our pattern on this vehicle. So when he got these parts, he got the wrong cam gear. Got the wrong cam gear. This setup would be for the newer design flywheel. Let me show you the older design flywheel real quick. I have one of these on my shelf. And this older design flywheel actually used, you saw in my original waveform on the 92 Caravan that I had in my waveform library, that you got groups of 4 windows that it reads off of the flywheel. Groups of 4. And the one that we have is not like this. So this gear does not belong with this flywheel, or vice versa. The other flywheel does not belong with the gear that's on this van. So wrong cam gear. And that makes sense with the guy that put this in. He swore up and down that his timing marks were right. He's pulled it apart 2 different times only to find out that the marks are lined up. The problem is the gear is wrong. Back to the screen one more time. Something I forgot to mention with Eric's post here is, and that's with this one, that had the same relationship we had with that triple notch we were focused on being off, was this thing had, the engine was replaced, and it came to his garage with a salvage yard engine put in it, and apparently they used an older model year, and they swapped the flywheel around to use on this old engine, and the old engine had the older style cam gear, and that was the problem on this one. So I'm not sure what year they did the switch. I've heard from a few other people it was around the 03, 04 model year, right where we're at. So just be aware of this for the future. So again, looking at Kevin's waveform here, 1, 3, 1, 2, 3, 2, 1. And look at my waveform on this. 1, 2, 3, 2, 1 space. Wrong cam gear. Now the thing about this, I would not have known that without having a known good waveform. A lot of you guys want to know, where do I get my information from? One of the resources I use on a regular basis is iATN, and I can't thank the guys that put this in here enough. Both Kevin and Eric for putting this stuff together, for guys like me, for the rest of you guys out there to be able to have this kind of resource to use in a case like this. We don't want to pull this thing apart 3 times, because this is going to be the 3rd time that these covers have been off, and this is not an easy engine to do it to. But what we know for sure right now, because of this information, is that we have the wrong cam gear in here. When did they change this? I don't know. Me being an aftermarket guy, I don't have all of that information. When they changed the cam-crank relationship, or when they changed the cam and crank signals. What I do know, what I can share with you, is the difference with this design. Unlike the other design, this design can start with the crank signal only. If I unplug this cam sensor, this engine will still start. And I believe that this engine will start without the crank sensor signal because of the cam sensor redesign. Now I can't do that here, I can't show you that because I have the wrong cam sensor signal in here, but I did it already, unplug the cam, it starts off the crank. The old design would not do that. So the coordination of the signals is different, gives the computer the ability to start with either one only, run in a default mode. And I guess one other thing that we can do, and maybe this is a little overkill, but yeah, that's what we do. The other thing that we can do is I want to show you what we're actually losing here. And let me set this back up, show you what I did. Channel C and D are connected to my injector and my ignition coils. So channel C is my green trace, is my fuel injectors, and channel D is my ignition coils. And I want to just get a shot of what I'm doing there real quick. Had a question about this just yesterday on when you want to use attenuators on this Pico, and I'm going to be looking at collapsing fuel injectors on this channel that may spike over 100 volts, and I'm going to be looking at a collapsing ignition coil on this channel that may spike upwards of 400 volts. That's when you want to use these, and that's going to reduce our inputs by 20 and protect our scope. So I have those set up, and I have my channels coordinated to go with that. Basically, I've told the scope that I have these in there. And that's done as simple as going to this drop-down menu and telling the scope that you have the 20-to-1 attenuator in there, and that is going to adjust the scales for you. So my scaling is going to be proper for both channel C and channel D. So let me start it. Let's look at all four of these now. Okay, a lot of information going on in the screen. You see the yellow trace here, that's your ignition firing events. Down here is your injection. There's noise in between the firing events because it's a multi-coil pack and they're all right next to each other, so you're going to get some interference from the other channels firing. Just to give you a quick view of this, let me pause it. And I'm going to zoom in on just this one firing event, just so you can see that that is an ignition event that's taking place. Pretty standard looking pattern, and zoomed out, of course, kind of hard to see that. And then here's your injector. This is really nice feature of the Pico to be able to do this. And you see that's the on-off voltage waveform of the fuel injector. So again, voltage waveform of the injector, voltage of the primary of the ignition. And again, this isn't necessary to show you this, but I want you guys to see what's actually breaking up on this. Don't put too much detail into these gaps that are in this top picture because we have a little bit of aliasing going on. Too much data for this screen time. That's okay. These are going to be fine. Focus down here on these two. As I raise the RPM, of course, our frequency is going to increase. So they're going to get tighter and tighter, but watch what happens when it starts to surge. Nice to have this waveform buffer in here. You see that our patterns here, we'll focus down in here and what we're actually losing. Injection, ignition, and if we look at the green trace, we're not really losing spark, but we're getting random firings of the injectors. There's one that's kind of in the wrong spot, and then you have a gap in here, and with a really long gap. And the thing about that one would be that it isn't just one cylinder that's being affected. This would be all of them. So I'm only showing you one coil and one injector, but if you can picture this, what's going on with this vehicle is all of the injectors are shutting down. Under load conditions, our injection is not correct. Now, why it's able to idle okay, I can't answer that, but this is definitely an injector issue, and it was caused by the wrong cam gear. Now, the cam sensor, very, very important on this design for proper injection sequencing. The coils can fire independent of this cam signal. I can unplug the cam sensor and have this engine run and start, so the computer is able to identify with that crank signal alone which coil to fire. But what it can't do without the cam signal is figure out proper injection sequencing. We need to have the right cam signal, and with this incorrect gear that's in here, it is firing this thing at random and different times and just really not able to run properly at all. So cam crank is incorrect. Thank you again, iATN, for letting me use the information. Thank you again, Kevin and Eric, for your uploads. And hopefully you guys learn from that and you get an idea where I'm getting some of my information. iATN is definitely my right-hand man. So thank you very much, and hope you guys enjoyed that.